Hey guys, welcome back to AlgoYogi. We are doing two-pointer series. Next problem in the list is array with elements not equal to average of neighbors. Let's go to the problem LeetCode. So it says you are given a zero indexed array nums of distinct integers. You want to rearrange the elements in the array such that every element in the rearranged array is not equal to the average of its neighbors. Really clear. I don't think it's that clear, but who would, I don't know if it has some practicality like in the code that we write on day-to-day basis, but anyway, they asked us, we'll do it. It's not that complicated, and we are doing two-pointer series, so we'll use it. We'll do it using two pointers. And they have given a little more description, that is like more formally, the rearranged array should have the property such that every I in the range in that the length, the element at I should not be basically it should not be equal to, is it equal to, no, yeah, it should not be equal to the average of the element before it and after it, right? So let's see. So I think you can't do it for the first index, like 0th index, because it doesn't have the first neighbor. But anyway, we start at the first element, not the 0th, second element I would say, and then you go up to the second last element, and then you basically check for those. So we need to rearrange these values, and how to do it, So I'm gonna switch the view here. So this is exactly what they want, and as let's go over their answer. The output that they have given us is basically they have rearranged the values as 1, 2, 4 and 5 and 3. So this is their answer, and let's see why this works. This works because if you take the average of 4 and 1, that's 5 plus 5 by 2, that makes 2.5, and this is not equal to basically 2. So this is not equal, right? And what if you take the average of 2 and 5? That won't be equal to, basically that won't be equal to, the average of 2 and 5 is not equal to 4. That's like 3.5. And average of 4 and 3, that's 7 by 2, that's 3.5 again. That's not equal to 5. So this is the way that they have arranged, but let's see how can we actually do it for ourselves, and we can return any pattern that satisfies the condition that's given in the return any arrangement of nums that meets the requirement. And the requirement is just starting at the first element and the second last element, they none of these elements should be equal to the average of its neighbors, right? So I think the best way would be, how about we sort this element? So when would an element for sure will not be equal to the average of its neighbors? So I think either this element is I would say greater than both its neighbors, or it's smaller than both its neighbors. So that means if both the neighbors are greater than this element, then their sum will always be, their average will always be smaller than the value that we are trying to compare it with, right? So let me actually, I'm just trying to log in here, and then we'll move on. Okay, yes, that will log in. So this is what I'm saying. So if I don't want, let's pick up this pair, And if I don't want the average of 1 and 3 be never be equal to 2, then I want to pick the these two neighbors as such they're either both greater than 2 or smaller than 2. So these are the two cases. So first case is like either this is 1, 2, and there was some value, let's say like 0, then which is not present in this case, but let's say it was there, then these two cannot have an average of a value that's greater than both of these values, right? Or let's say those two values were 3, 2, 4. This is the basically triplet, and if you take the sum of these two values which are already greater, so if two greater values of the value x, they cannot have an average that's basically equal to something smaller than both of these values, right? I hope you understand. So what we really need to do is we need to alternate the values in a sorted array. Why? Then we can make sure that, okay, so this is what I mean. Let's say this array is already given to us as sorted, but we have two pointers, pointer I and pointer j. Then I want to arrange my result array, result pattern that I'll be returning, as I take j, the first element, then I take this element, then I basically must have incremented I, and then I take this, then I take basically 4, and then I take basically this 3, and then I'll make a check if they're equal or they're not equal, right? So I don't want to push the same value for both I and j. So I'll keep going until I is lesser than j, and then I can just return this. This would be a valid arrangement. Why? Because if you see, this 5 has neighbors both smaller than this value, and this 2 has neighbors both greater than this. This 4 has neighbors both smaller than. So this is basically a pattern that's alternating the smaller and greater values basically. So if you're sorting the array, in this case it's already is. So if you have a sorted array and you pick the smallest value, then the largest, and then next smallest, then next largest, not like largest, but you coming together towards each other, then it's like second largest, second smaller, or stuff like that. Okay, so I think now I guess we can start coding up. I think this is pretty clear, and it will be big of n time complexity, and space complexity was also going to be big of n because we are using this extra memory to store the result. All right, so we're gonna do a lot of coding. So let's have a result array, which is this, and then let's sort our nums. So nums.sort and let's have our I pointing to 0, and then let's have our j pointing to basically I'm gonna say nums len nums -1. Okay, so since we want to use all the values, so I would say if or I could say I'll have a while loop. So while I think let's just try with I. If I is less than or equals to j, then we keep going. Okay, so what I'll do is result.append my nums at I, and then I'll increment my I, and then I want to check if I is still lesser than j, then I will do this. I will append j I'll tell you why I'm doing this, but I want to see if this will actually work. So if I is less than j, yeah, okay, you know what, this works, and then j minus 1. Okay, so the reason I'm doing it is like here I'm checking if I is less than or equal to j. So there might happen when, you know, I appended I and j was like right next to it. So if I'm appending ith value, that means we do not have any more values. And if I don't make this check, now I and j became equal. So if I don't make that check, then I will be adding that value again. I don't want to do that, you know. So that was easy, right? And then we can just return result. And okay, let me zoom out. I always forget to just, you know, make it look a little nicer. Now we can zoom out. Let's run our code on example. Yeah, this passes, so let's submit it. Awesome. Okay, so let's write down the time complexity, which is big of n log n, and that's because of this sorting we are doing of the array here. Otherwise, this particular algorithm, you know, this is the main two-pointer approach. If the array was given already sorted to us, then it would be big of n. Like now it's you know, quick sorted, merge sort. They're both n log n, and they're probably the best sorting algorithm. And I think pivot one is also pretty good. And space complexity is going to be big of n. Okay, so I think we're done, and we can go back to AlgoYogi and mark this solved. I still haven't fixed this problem. I will later. You know, you have to click it twice to basically mark it done. Okay, bye bye.